All right, so in this video, we are going to do the entire curve sketching algorithm for this equation over here. So the first thing we want to do is we want to derive the equation. That's going to be 3x squared minus 6x minus 24. Then we want to make the derivation equal to 0 to basically find our critical points. And we want to factor this equation over here. So I can common factor out a 3, left with x squared minus 2x minus 8. And I need to factor this with my man method. So what multiplies to negative 8 and adds to negative 2? It's a negative 4 and positive 2. So my two solutions here are basically x equals to 4 and x equals to negative 2. These are my critical points. Once I find my critical points, I need to classify them as maximums and minimums. In order to do that, I'm going to do a number line, and I'm going to put my critical points on my number line. And now I'm going to test all these three ranges here to see whether they are increasing or decreasing. I'll start with testing f prime of negative 3. You want to sub a value from negative infinity to negative 2 into the derived equation over here. So I'm going to sub in negative 3 into that equation. I'll do this in my calculator. And I get positive 21. A positive value means you're increasing. So I'm going to draw my graph going upwards from left to right because that's increasing. Then I'll pick a value between these two. I'll just do f of 0. And f of 0 is just negative 24. If you have a negative value in your derived equation, it means it's decreasing. So I'll draw an arrow going downwards. And then I'll test a final point over there. I'll test f of 5. So if I do f of 5 in my calculator, I get 21 again, which is a positive value, which means I'm increasing. So now I can tell if I connect these two, this is a maximum over here. The x value of the maximum is negative 2. And to find the y value of the maximum, I have to sub back in the original equation, not the derived equation. So I'm going to sub in negative 2 into my original equation. And I get positive 29. So I have a maximum at negative 2 and positive 29. That's my local max. These two, if I connect here, are both a minimum. The x value is positive 4, and I'll sub this again into the original equation to find my y value. I get negative 79. So once I get my min and my max, I can do my intervals of increase and decrease from this number line over here. It's pretty simple. I'm increasing from negative infinity to negative 2, and I'm also increasing from positive 4 till infinity. So two intervals of increase. My intervals of decrease are just from negative 2 till positive 4. Once I've completed my intervals of increase and decrease, I want to do my second derivation to figure out my inflection points and my intervals of concave up and concave down. I'm going to derive this again. F double prime of x equals 6x minus 6. You want to make this equal to 0 and solve this. This is a linear equation, so it's simply solving. You don't have to factor your better to just solve. So I get x equals to 1, and this is my inflection point. Now I can find the y value of my inflection point by subbing in 1 into my original equation again. And I get negative 25. So once I get my inflection point, I'm going to do a second number line, and this number line is going to be for my concave up and concave down. I'll put my inflection point here, and now I have to test these two ranges, basically from negative infinity to 1, 1 to positive infinity. I'll test a value here. I'll just take 0. So we're putting this in our double derived equation. So f double prime of 0, if I sub in 0 in this equation, I get negative 6. Negative means you're concave down. And then I'll test this range here. I'll do f double prime of positive 2. If I sub in 2 in this equation, I'll get 12 minus 6, which is positive 6. Positive value means you're concave up. So my intervals of concave up are just from 1 to infinity, and my intervals of concave down are just from negative infinity to positive 1. The last thing I'm going to do is I'm going to sketch my graph now. So I'll start by just putting my maximum and minimum point. So negative 2 and negative 29 is approximately here, and positive 4 and negative 79 is, oh, sorry, that's a slight mistake. This is a positive 29, negative 2 and positive 29 is here. And 4 and negative 79 is down over here. And then I have my inflection point at 1 and negative 25. So 1, negative 25, somewhere approximately here. This is not maybe completely to scale. This point should technically be a lot lower, but because it doesn't really fit in the page, I just put it here. And since it's a sketch, that's okay. And then I know that for my original equation, my y-intercept is positive 1. The y-intercept is just going to be slightly above the origin because the scale is big. And now I can just draw my graph. So that is all going to be concave down. So from 1 till this is all concave down basically. And then this is going to turn concave up after this point over here. And it's going to be concave up till the end, and then the increasing and decreasing will follow along with your maximums and your minimums. So this is the graph right there, and then we can label the points. So this is negative 2 and 29, y-intercept is 1. This is positive 1 and negative 25. And the last point here is positive 4 and negative 79.